required to integrate the function with respect to x at interval of 0 to 1. If you are ready, let us solve it. Rationalize the denominator of the given function by its conjugate pair as shown on the screen. Simplify the result, we get 1 minus the square root of 1 minus the square of x. Replace or substitute the given function with this final result obtained, which we will integrate. Decompose the result obtained into two functions. Integrate one to get x and leave the second function to be integrated later. We call this new result equation 1. Recall from trigonometric identity that cos y equals the square root of 1 minus sine square y. We call this equation x. After simplification, x equals to sine y. We call it equation y. Differentiate both sides of equation y. Dx equals to cos y dy. Let us integrate the square root of 1 minus square x. Thus, substitute values we obtained for the integration of 1 minus square x to x equals to the integration of cosine square y equals. By trigonometric identity, cosine square a equals to half of cos 2a plus 1, which when decomposed equals to the sum of half of cos 2a and half. This result, when integrated with respect to y, equals to cosine square y dy. Decomposing cosine square y dy into two separate functions so that we integrate the second function to get y and we leave the first function to be integrated later. We call this new result equation 2. Let us integrate cos 2y dy. We assign u to be equals to 2y. This implies that dy equals to half du. But integration of cos u with respect to u equals to sine u. We ignore the constant term as it is definite integral we are solving for. Using this relationship we found between integration of cos u to u and sine u. Remember to bring out constant multiplier number 1/4 out of the integral sine and integrate cosine u with respect to u to get 1/4 of sine u within the given integral interval of 0 to 1. Substitute u equals to 2y and we have integration of cosine 2y with respect to y equals to 1/4 multiply to the integration of sine 2y with respect to y. Recall that, from equation y, sine y equals to x. Take sine inverse of the equation and we have that y equals to sine inverse x. Substitute values into equation 2. Solving the decomposed form of cosine square y with respect to y equals to the sum of the product of 1 over 4, 2x and 1 minus the square of x and the product of half and sine inverse of x. From equation 1, the integration of the given function equals to the sum of x and the integration of the square root of 1 minus the square x, which we integrated the second function, substituting values and simplifying on the way to get the result shown on the screen. Our integral interval is from 0 to 1. From our integrated result, there are 3 separate terms. 1 was obtained after finding the difference between substituting 1 and 0, the integral interval. Thus, starting from the second integrated result, put 1 and 0, respectively, in place of x and their difference. Repeat the same procedure in the third integrated function. Therefore, the integration of the given function within the allowed interval equals to 1 minus 1/4 of pi.